Welcome. Thrilled to be here. Thank you very much for having me here. Even though it's a long way from anywhere that I live, I do like to travel. I do like to speak to the community. I've been working with Oracle for about 25, maybe getting on for nearly 30 years now. That's with Oracle technology. I've only worked inside Oracle for 2 years. So I'd like to think of myself as a member of the user community for maybe 95% of what I'm going to talk about today, and a member of Oracle for 5%. So my name's Connor McDonald. I come from Perth, which is here in Australia. It's pretty much one of the world's most remotest cities. The next city is Adelaide, which is a three-hour flight. So there's not a lot to do in Perth, but I work from home, and so it's good fun. Obviously, we have the typical ego slide. I have a blog. I have a YouTube channel. I'm writing a lot more videos nowadays, and that's a reflection on perhaps the world as we see it now. The younger generation of people who are getting involved in IT, they're a YouTube nation nowadays. Even my children now, if they want to learn how to do something, they'll go to YouTube first. So I'm trying to sort of shift that way to get into producing more videos now, so we can appeal just not to people of my generation, but also people younger as well. And if you're not on Twitter, I'd encourage you to get on Twitter. Don't get me wrong, I'm a skeptic when it comes to Twitter. I use it a lot, but I'm a bit cynical about it because, what do you do in 140 or 280 characters? But the reality is the US loves Twitter, right? They are obsessed with Twitter. And the fact is the vast majority of Oracle professionals inside Oracle organization are based in the US. So if you want to keep abreast of what's going on in terms of product announcements, new features, etc., Twitter is the place to be. Even if you never tweet, get onto Twitter, right? Follow some key people in Twitter. Please follow me. Hopefully my tweets are somewhat interesting most of the time. But yeah, so get involved in Twitter because it's a great way of staying informed. And ultimately, that's why we come to conferences like this, to be better informed. This is what I do most of the day. I look after the AskTom website. I've known Tom for about 20 years, but in 2015 he retired. He's just relaxing in his home now, and I email him from time to time and say, are you still interested in technology? And he's like, screw that. Yeah. He's having a nice relaxing time. He's retired. So we resurrected the site in September 2015, and now myself, is Chris in the room? Chris, you here yet? Chris at the back. So myself, Chris Saxon, Maria Colgan, and some behind-the-scenes helpers, we look after the AskTom site, and hopefully you find it a really valuable resource. So today I'm talking about SQL and PLSQL. I love them. I've written books on them. I've worked with them forever. I'm a huge fan. But the question is, why talk about it? Because after all, SQL has been around since before Microsoft Windows. That's how old it is. It's over 30 years old. And why would we talk about a technology that's that dated and that mature? One of the reasons I like doing SQL talks is there's this prevalence of this thing called NoSQL nowadays, right? And I have no problem with NoSQL except the name. It's just dead wrong. It's got nothing to do with SQL, the language. NoSQL was really about non-relational document-style databases and the like. So it's amazing how many people I talk to, they go, I'm not really interested in SQL because NoSQL's the thing. Right? Well, SQL is the language. In fact, the people that invented NoSQL are now putting out quotes saying, we've realized that actually having a SQL language, a SQL dialect, is actually critical for us to actually succeed. And that's why I like pushing that agenda that SQL, the language, is actually super important as an IT professional. I don't really care what technology sits underneath that, whether it's relational database or NoSQL or whatever. SQL, the language, is the dominant force for us to succeed as IT professionals. Second reason why I like to talk about this is it's so easy to get wrapped up in cool tech. Now, what's the coolest thing nowadays? Microservices. Right? Everyone's talking about microservices nowadays. And I went and looked up microservices. But the reality is SQL invented microservices. What do I mean by that? This is what it says on the wiki site for microservices. It's a fine grain to perform a single function and each service is minimal and complete. That's exactly what SQL is. Does one function, it's minimal, complete, does what it says on the tin. SQL is the first microservice. And yet everyone says, I don't want to learn SQL because that's old. I need to learn about microservices because that's the future. Well, SQL is a microservice. What's overtaking microservices nowadays? Now it's all about API-based computing and Lambda and functional computing, etc. like that. Well, once again, over to the wiki, abstracting the underlying implementation, we just describe the behavior that have multiple implementations. Well, SQL again, right? We have an optimizer. We don't know how that's going to get run. We just know what it provides. And in terms of API in a more classical sense, well, that's what PLSQL is. We have no idea what myproc does under the covers. We just know it exposes a ref cursor to us. So all these cool technologies, microservices and APIs, are just reinventions of stuff that we're using all the time, which is SQL and PLSQL. So that's why I like talking about them. Now, a key point. This session is about what I call new features. I think the abstract says the newest features, right? And it is new features, but I'm not going to talk about 18C. My definition of new is hopefully stuff that you might have not seen before, or you may have seen but not used it in a certain way. And the reason I'm doing that is two reasons. One is, this is how inside Oracle we'd like to see the world, right? Inside Oracle we think, yeah, 18C's out, everyone's going to move to 18C like in the next month or so, and no one's going to have any other database ever. That's this perfect dream we have inside the organization. But as I said, I had 28 years outside Oracle, and I know that this is more the reality of the world, right? We're all here, and I was being generous here because I could have put 10 and 9 and 8 and 7, but this is sort of more the reality of the commercial world. So I want to focus on features that you can hopefully use today, as opposed to, oh look, when 18C comes along. Now don't get me wrong, Chris will be doing an 18C talk later on this week. And it's critical that you actually know what's in 18C, even if you're not going to 18C soon. Because if you don't know what's coming in the next release, it's amazing how much you can reinvent technology that's given to you for free. So you don't want to reinvent the wheel if something's already coming in 18C. So I'm going to talk about not so many 18C features. Chris is going to talk about explicitly 18 features, which hopefully gives you double the value and also keeps you abreast of what's going on. The other thing this session is not about is being a smartass, right? I've been to countless talks where someone gets up there and says, look at this program I wrote, and isn't it so awesome, and aren't I super smart for doing it, right? That's all well and good, but it values you absolutely in no way, shape or form. I don't want to sit here and try to prove how clever I am to you, right? That doesn't benefit you in any way. So the fact is we can do anything with SQL and PLSQL. That doesn't necessarily mean we should. Here's an example of stuff we won't do today, right? Here's an SQL statement. We're not going to go through specifics. That's page 1, that's page 2. I didn't write it, so don't blame me, but it's pretty cool. What does this do? Well, you pass in, people are probably familiar with Sudoku, or Sudoku, depending on how you pronounce it. You pass it in as a string in the shape of a Sudoku board, and that SQL will solve it. Now you're going, oh, I don't believe that, but let's have a look. So there's the board. Hopefully you can see the font's large enough. Here's that first page of the SQL. There's the second page of the SQL. We run it, and there's the solution. Now you're going, yeah, right. This is a bit of trickery going on. But if I take out the terminating clause so you can see the SQL as it works, you can actually see what it's doing. It's just brute force going along through 81 digits, just working its way along, and eventually, if my laptop can keep up, it'll just work its way along, filling in all the blanks, and 81 digits is effectively the box, and then at the end, we just simply print it out in a nice, pretty format. Now, don't get me wrong, I know at the end of this session, the only thing you're going to want from me is that script. But we don't want to focus on stuff like this. Slideshow. Because this is the percentage of you that need to solve Sudoku with code as part of your day-to-day job, and this is the percentage of us that need to get real stuff done. So this session is not about clever tricks with SQL and PLSQL, it's about getting real stuff done. And I'm just going to basically go, I'll take my phone out so I can keep an eye on the time. I'm just going to keep going pretty much as hard as I can, as fast as I can, until we run out of time. We might get through all the content, we might not, but we'll just keep chugging along. If you get bored or just feel like, oh my God, I'm being clobbered with slides, then tough. We've already got 36, we're about 10% of the way in. So a bit of controversy. So for number one, some controversy is the first thing you need to do as an Apex developer or any kind of developer in the Oracle space is to be friends with your DBA. Now, that's a tough one because often in organizations there's a bit of a chasm, a bit of a gap between the DBAs and the developers. In fact, it amazes me organizations still seat them in different places. The DBAs sit in the system programming area and the developers sit somewhere else and they should never meet. And we feed this ourselves. You ask a developer what a DBA is, they say it's some old guy, he terrible footwear, drinks like that. And then you go visit the DBA and you say, what do you think of those developers? And they go, well, they're those Red Bull drinking, Justin Bieber fans, don't know how to wear their jeans properly. And you get this lot of animosity between us. And that's a problem because DBA stuff really matters if you're going to be a successful developer. And let's look at a quick example of that. So here's a table called My Transactions 1. It's got some columns. It doesn't really matter what's in them. It's empty at the moment. I'm going to put 200,000 rows into it. Tab 200k is just 200,000 rows from a random table. I'm just doing some random number generation in there. So there's 200,000 rows in there, and we'll commit that away. Let's now do some exploration of how this table is going to work. I'm going to do some queries for a particular customer 160. The key stat here, if you're new to using tracing, is this one, consistent gets. That's effectively a measure of how many IOs I had to do to satisfy that query. I did 520. Now, if I run it again, it's a bit better, 378. The reason for that is, the first time I ran that query, I actually had to do some work to work out how to run the query. I had to work out what the table name was, what the columns were, whether that was a valid SQL. There's a bit of work that had to go on. But now that I've done that, 378 will be pretty much what it costs. No matter what I do, each time I run it 378 times to actually run that query. Let's now create a table called My Transactions 2. It's got the same columns. And in fact, it starts off as empty. And just to prove that they're going to be the same, I'm going to copy all the data from Transactions 1 into Transactions 2. It's the same data. Let's look at that. Same number of rows, 200,000 in each table. If I do a simple minus, I can see there's nothing in 1 that's in 2, and there's nothing in 2 that's in 1. These tables are identical. I've even got the same indexes on these tables. One for the customer ID, one for the transaction ID, so they look like normal kind of transactional tables for customers. So, just to recall, transactions table number 1 for customer ID 160, 378 IOs, nothing has changed. Let's now try transactions number 2. 123. Well, that's looking promising. That's 3 times faster already. And that's the first execution. Remember, that's the one that has to do more work. If I run it again, I'm down to 19. And that's repeated. That's consistent at 19. So this is a demonstration of I've got 2 tables identical in data, yet one of them is 20 times faster to query for that particular customer. And in fact, for any customer in that table, it'll be 20 times more efficient to query it. That's where your DBA can provide enormous value to you, right? The DBA in this case me, has structured the tables in a particular way, knowing what your requirements were as a developer. If you can talk to the DBA and say, for me, customer queries are critical, the DBA can assist. So have a good relationship with that DBA, you get the benefits from it. In case you're wondering, we're not going to explain how that works. Come see me later on today if you want to, but that's really, it's beside the point. The point is knowing your DBA matters. Number 2, PLSQL resolved expressions. So I'm going to sort of flip-flop between SQL and PLSQL as we go. Sometimes a few more SQLs, sometimes a few more PLSQLs, and we'll just keep chugging along. As long as you're on 12 and above, we notice this great thing called longer names. Right? And I've been waiting for this like forever, because I started around the Oracle 6 kind of time frame, and we had 30 characters for names then. And then every release you're thinking, oh, it's going to get more, it's going to get more. And it never does. It's always been 30 characters for tables, columns, etc., etc. And then when Oracle introduced things like advanced queuing and have prefix on tables, you get things like, well, your queue can only be 20 bytes long. because we need 10 characters for the AQ dollar and all that kind of stuff. So it was just a pain. And longer names is great because a table with my column isn't very useful, but once I have once the limits have been lifted, I can actually put a lot more value into the name of my columns. And as we know, code should sort of be self-documenting. So the more value you can put into column names and table names, the better it is for the next developer who comes along and has to look after your stuff. You're limited to 128 bytes, and the problem is the moment we did this, this happens. Right? Your applications start crashing all over the place, which seems a bit counterintuitive. But as we go digging around, we might find some code that looks something like this. I've realized that table names are always 30 bytes. They're never going to change from 30 bytes. So I've used varchar 230. Someone's created a table name longer than 30 bytes, and my application has now crashed because I can't jam 60 bytes into a 30-byte varchar. That's fairly obvious. So, that might be the database code, but your applications start crashing. In terms of preparing for that, in terms of being able to build applications today that might be on 11 or 10 or 12.1 that actually will work into the future, right, we've introduced the concept of using expressions in place of literals for your variable declarations. So for example, I can declare a constant now in PLSQL saying that constant is length 30, but I can now refer to that variable inside a varchar2 definition. I should note that all these slides will be made available on the AskTom website, so feel free not to have to scribble notes or anything, that's fine. And obviously it's being videoed. So you can start using expressions now inside these variable declarations. Now it must be resolvable at compile time. So when the PLSQL is compiled, it must be able to actually work what that value out will be. So for example, even something as simple as toNumber will actually not compile, because it's not allowed to be any kind of function on there. It must be either a constant or an expression, not a function. That seems an unnecessary restriction, but we are where we are. At which point you're probably thinking, what have I really achieved here? All I've done is move this constant of 30 from here up to here. I'm still going to have to go change that the next time we change the file length names or the table length names. I haven't really solved anything. Well, we've also introduced a pre-delivered constant for you, which is aura max name len. And that will be kept updated on any version of Oracle you choose to use it on. So at the moment in Oracle 12, we have 128 bytes now for a table name. In Oracle 23, it might be 256, and in Oracle 27, it might be 512, etc. But whatever it is, that will be there to keep up to date. And the good thing is you can start today. Even if you're not on 12 today, you can do things like this. If I'm on a version less than 12, then use the old style syntax. Otherwise, use the new style syntax. So that's now future-proofing your PLSQL code using a bit of conditional compilation plus this new feature. So it's a cool way of making your code really robust today for the foreseeable future. Some people in the room who are familiar with PLSQL might be saying, well, I could have avoided all that hassle by just using the %type anchor. If a table name is 30 bytes, just use %type, job done, problem solved, why not do it? That's true, but what about things like this? If I'm doing select owner concatenated with, for example, a dot, so I'm getting a fully qualified name, what do I put in there? Well, as I said, as long as it is resolvable at compile time, for example, like that, that'll work fine. Right? So that's an expression that's resolvable at compile time. So, you can actually use this to take advantage of future-proofing your code in nice ways. Number 3. So let's try that again. Longer names have come into my application, but I've done compile time resolvable sizes, so I'm pretty sure my application's not going to fall over. My job is done. And then the phone rings, and your application has crashed, even though you've taken this effort. And the question why, let's look at, I'm writing a little Apex application called my DBA tools, and one of the things is looking at columns for tables. It might have started off as something like this. There's the table name, there's the column names, but I didn't really like that, so I turned it into something like this, which is a little bit more intuitive to me. That's all well and good, but I've just come along and said these things can now be really, really long. In fact, someone said, great, long column names, and they start creating tables with columns like this. all of a sudden, when I want to start concatenating those values together, my error comes out. I'm using the listag function, which came out in Oracle 11, but it's capped at the maximum length of a varchar 2. So where I could concatenate 30 byte columns before, now that they're all 128 bytes long, I've now blown up my Apex application again. That is tough to solve, because if we look at how a listag works, and this is a query that simply, as it works its way through the columns, builds up the listag function. For column number 1, obviously the concatenation is just the first column. For column number 2, it's the second one. Let's assume that this point here, just before department number, is the maximum length of a listag. So let's assume that's the cutoff point. How do we know when to stop? We only know that we're going to cross this limit when we actually get to the next column. By that stage, it's too late, because I'm about to blow up my length. So it's sort of a chicken and egg kind of problem. And what we used to do in the old days is we'd often go back to first principles. We'd write a function to loop through it and make sure it didn't get too long and then stop at the right point. It's painful and messy. So what we can do in some of the more recent releases of Oracle is we have better overflow handling to make your applications a little bit more robust. So with listag, you can now say, if I get to an overflow condition, then just truncate it. And by default, here's my huge length of list columns, I'll get an ellipses, 3 dots, and then the number of characters truncated in brackets. That's the default operation. So rather than crashing, it simply says, I had to stop here. And you can get control over that. You can say, I want to truncate it, and rather than having ellipses, I want the word, for example, more. So that might become, say, a hyperlink in your Apex application. Or I can have things like on truncate more, but don't give me the count. So it just has the word more, but no counting. You have nice flexibility over it, and obviously you can actually have no keyword, and that's just literally a straight truncation. We don't tell anyone that actually truncation occurred, we simply say that's where we stopped. But the key thing with all those examples are your application didn't crash, and that's obviously the key thing. Number 4, column level collation. Every system that I've worked on struggles with case. Now, I want to stress that the correlation here is not because I'm a terrible programmer, right? It is my fault though. And why? Because I have a problematic surname. Let's look at our names table. It's got a surname in it, and already we've got some dramas here, right? We didn't constrain it. We've got mixed case in there, which we might not have wanted in our application. A check constraint's gone missing, etc. But this is what we often do to solve these things. To have a consistent presentation, we'll use, for example, a function called initCap. And that makes the data nice and clean and makes our applications look pretty. But this is why it's my fault, because when you have someone like McDonald who comes along, initCap doesn't work. Yeah, and I'm one of those kind of people that phones up the help desk and says, that should be a capital D, please fix. And then they go, well, we can't fix that. And I'm going, what do you mean you can't fix that? And it's amazing how complicated the most simple things can be. And in this case, that's a problem. And it just gets worse, because the moment you start having things like mixed case and you start hiding that from your end user, what you're really doing is hiding a data corruption issue. And so we often see things like this, where I'm selecting from my customer table where the customer name equals Adams in uppercase, and that looks fine. I got the 1 row back. That looks like my application is working fine, until I run this query and realize there was actually a whole stack of people called Adams. But unfortunately, because I'm allowing mixed case, I had to use an upper around it. And so I then jump into my code and I say, well, to make sure I'm returning all the rows I'm meant to be returning, I'll put an upper around all those columns to make sure I'm getting case-insensitive queries. And that's just like a bad idea, because when you do that, this is the thing that all your users see. Right? They simply get bad response times typically, because what's the most common index you'll have on that? Probably just on the customer name. And therefore, when you use an expression around a column, you get table access full. Most of us are familiar with those kind of restrictions inside the database. How do we fix it as developers? We speak to our DBA, we say, look, we need another index. We've got that index because some of the app uses that. Some of the app uses where cuss name, some of the app uses upper cuss name. We need 2 indexes. Now, every time you add an index, what you're doing is getting your DBA offside, because DMLs become slower, you get more contention for index blocks, you're consuming more redo and more undo. But let's face it, as developers, when someone presents this evidence to us, you know what we do? We go, yeah, I could care less. You know, we don't really care. It's not my problem. That's DBA stuff. And that's true. And you might think, well, the DBA is already looking after 100 indexes across all these different tables. Index number 101, he's never going to notice. He's not going to even know. It'll just be tucked away in my deployment script. He'll never see it. I'm going to be clean. Until the phone rings. And this is where you get these hidden consequences inside the database. The DBA wanted to do this, reclaim some space in that customer's table. And you can't do it if there's a function-based index on that table. And that's why it's important, going back to point number 1, to actually have a good relationship with your DBA. You get on the phone and say, I want to put a function-based index on. And he's going to go, actually, I'd rather you didn't because it's going to break one of my maintenance jobs. So it's important to realize that just throwing function-based indexes on things actually isn't just a nice, simple solution. You might have all sorts of breaking consequences down the track. There's a better way, and that is a thing called column-level collation, which is this particular point. What does column-level collation mean? It's actually a declaration you assign to a column. I'm saying I want to collate this in a binary CI way. What does that mean? Binary case insensitive. So I've recreated the table with that. Let's now look at an example of that same customer table. An index on customer name, I do a query where customer name equals Adam, and I use the index because there's no expression. Big deal. Right? That just looks like stock standard Oracle to me. But let's look at the data that came back. I did where customer name equals uppercase Adams, but I got all 3 back. I did a case-insensitive query without having to use the upper expression around the column because of this case-insensitive binary collation. That's pretty cool. There's binary CI, which is for case-insensitive. There's binary AI, which has absolutely no benefit for me, but huge benefit for people in Europe because it means I pick up accented characters as well. So I searched for Adams, but I got an accented A as well. So obviously, of particular use for the German audience. But you can see now that the cool thing is there's no ugly expressions around here. I'm getting advantage of the index even though I'm getting case-insensitive data. You can apply it to a column. You can apply it to an entire table. You can even apply it to an entire user, such that every varchar2 column created from that point onwards will actually be case-insensitive or accent-insensitive. I should say, yeah, it is new columns only. So if I do alter table people, default collation, binary AI, from that point onwards, all new columns will be pick up that thing. It will not go and retrofit it to existing columns. A key point is your DBA, remember, friends with your DBA, he needs to make sure the database is set to max string size extended, which basically means you can have varchars up to 32K. If you're at the standard size, which most databases often stay at, you can't take advantage of this feature. So once again, friends with your DBA. Number 5, deprecating code. Probably one of the very few criticisms of Apex, and it's always tough to talk about criticisms of Apex at an Apex conference in front of an Apex crowd, but is probably one of the most common criticisms is its ability to collectively work on the same artifacts. Yeah, you might have 1,000 developers all working on the same app. And generally in the docs, our recommendations tend to be, well, maybe split that up into different apps, etc. The team coding elements have got better and better every release, but it's been a source of some criticism. So when you're working on PLSQL objects that are used by Apex, you want to take care in terms of how you deal with them, how you make sure you don't impact other people. And continuing on from that previous example, here's some code now which is no longer good to me because I've managed to fix this with collation case insensitivity. So this cursor definition here is no longer good to me, right? Because I really don't want to have the upper in there. Now, where's that used? That's actually pretty tough because this is a package spec. So this cursor can be used inside the package, but also by any other piece of PLSQL in existence because it's declared globally. So finding where that's going to be used is tough to do. What we really want to do is do something like this. And this is what we probably do today. We'll go in, we'll put a comment in there saying, look, I need to leave this in here because I don't know who's using it. But I'll put a comment, look, please don't use this. We're now using case-insensitive collation, so please just use where customer name equals p name. Don't put the upper around it. And we might send an email out, to the department saying, just to let you know, this is the check-in, please check the commit log, etc. Don't use this anymore. Let's face it, as a developer, when you get emails from someone, who says, look, can you please not use it anymore? You sort of go, does it impact me? I don't really care, not my problem, etc. And this is the cool thing with deprecating code in more recent releases of Oracle. We have a pragma now to let you do this more forcefully. I can actually say pragma deprecate this get customers routine. And I say, look, please use get cust CI instead. It doesn't break the code. What it does is if I set PLSQL warnings to be on, then when I compile process customers, I'll get a compilation warning. It still compiles okay, but I get a warning saying, by the way, this pragma says, look, don't use get customers anymore, use get CI instead. So that's quite nice. It's a way of more explicitly letting development teams know when they try to compile artifacts that they might be using some deprecated objects. Now, if you're anything like me, a compilation warning to me is, does it run? I'm good. If it compiles, I don't care how many warnings I get, I can run it. That's not good advice, but that's maybe the way of the world. What you can do now is you've given people a month, you've told them, look, check it out. You can change the PLSQL warning level to this, which now says it now won't compile. So it's a nice way of introducing deprecation. You can say, I deprecate the code, you get a month where you're going to get a compile warning saying, don't use this code anymore. And after a month, then it becomes broken code. So you can sort of escalate that as you go. So deprecating code is a nice way of actually physically communicating to your development teams what's going on in the code base without just sending an email and sort of hoping for the best. Number 6, trip down memory lane. As I said, I've been working with Oracle for way, way too long. And this is probably the way we currently see Apex. It's this magnificent product totally encircled within the Oracle ecosphere, right? And that's how we've built most of our Apex applications, right? And this is a beautiful time of our lives, right? And it's all going downhill really fast because this is happening, right? Apex is a magnificent tool, and with anything that's successful, everyone wants it. Everyone wants to use it. And so now Apex, the demands on Apex are growing such that people say, I want to be able to consume non-Oracle data sources into my Apex apps. I want to be able to have Apex talk against non-Oracle data sources. And they might come from REST, they might come in JSON, etc. So it's great for Apex in the sense that it's a recognition that Apex is just so incredibly popular and successful. But it also makes our life just hell, because it's so much better to have data coming from a database like Oracle than just sporadic content from anywhere. And in particular, once you start getting into things like JSON as a data source, we have problems like this. Someone says, look, here's some stuff, here's the created date. And that's easy enough to convert to a date. But here's another piece of date information in that same JSON fragment, and they've chosen something else. And of course, it can be anything. That's what JSON is. It's totally flexible. People can pass you whatever they want, and rest assured, they're just going to assume that you can handle it. What happens when we start consuming REST service? Generally, your Apex applications, in fact, any applications generally just go down the toilet, because that assumption that all the data coming into them is nice and cleansed and pure goes out the window. We now have to be much more pessimistic with data as it comes into us. I know that's a bit of a sort of a gloomy term, but that's the reality. If we're going to be powerful enough Apex developers to accommodate any kind of data coming in, we have to be more stringent and pessimistic with our data. That's a problem, because I've got, for example, that JSON fragment exposed as an external table so I can view it relationally. I know there's a created date in there. I'm going to try to do a to-date on it, and I get an error, because they could have put anything in that string. How do I solve that problem? How do I want to convert to date all these columns where, well, I only want to do it if that's a valid date. How do I know that's a valid date? And what we've done in the past is written a PLSQL routine. We pass in the string, and it'll maybe try a few different date formats or whatever, but it's difficult. And getting back to point number 1, which I keep harping on, The moment you put a PLSQL function into your where clause, you know what happens then, don't you? Your DBA gets on the phone, and they just absolutely lose their mind at you. Because they're going, you can't call PLSQL from SQL, it's slow, it's context switching, it's inefficient. There is some truth in that. So let's not bag the DBA too much. But how do we solve it? It's a chicken and egg. How do I convert to a date? Only those things that I know can be converted to a date. We got some new functions that you can take advantage of in recent releases, one called validate conversion. So here's where the problem was. The created date in my JSON string was actually, someone put this in one of the rows, the 54th of August. That obviously is never going to be a date. What I can do now is use this new function, validate conversion, take that string, try convert it to a date using that format mask. If I can successfully convert it, return 1. If I can't, return 0. So effectively I can prune out the invalid data, the most important thing, without having my application crash. This SQL runs now. That's important. Being pessimistic with data is going to be important. The cast function inside Oracle has been similarly extended. Here's my salary column. Once again, in the JSON structure, someone decided to put a comma in there. Now, it might have come from an Excel spreadsheet, for example, whatever, but that's not a valid number by default inside Oracle. But I can say, take that salary string, try convert it to a number. If I can't, return me a -1 on an error. And so I'd get something like this. Now, these are two different ways of tackling the same problem. The first one actually removes from the result set that particular value. This one simply converts a legal value into something that's more palatable. So you can have control over how you want to process bad data. The cool thing is, all the standard functions we're familiar with, toDate, toNumber, toTimes, have all been extended the same way. You can have this default on conversion error extension to them as well. So once again, being pessimistic with data gives you applications that will stay up longer. One thing I will talk about is, if you've got some nice developers in your community and they're providing all the dates in their JSON fragments in that ISO 8601 standard way, one of the nice things in 18C, this is one of the very few 18C things I'll talk about today, is we now have a 2UTC timestamp, which it'll take pretty much any of the standard ISO 601 formats, 8601 formats, and give you a valid timestamp at the end of it. So that's pretty cool. Number 7, how am I going for time? Oh, we're cruising along. Partitioned outer joins. Been around for a long time, but I see them very rarely in the wild, so I thought I'd talk about them. Let's look at a simple example here. I've got a list of time slots in which I'm allowed to book a meeting. So in this particular workplace, I can book a meeting at 8 a.m., 9 a.m., up to 4 p.m. Nothing beyond 4 p.m. What a great place to work that would be. And here are some of the bookings. Some of the bookings are, Pete wanted room 2 at 8 a.m., John wanted room 1 at 9 a.m., etc., etc. Now, how do we bring those two data sources together? If someone says to me, give me the bookings by hour, well, that's just a conventional outer join. Left outer join, time slots to bookings, and we get all the hours of the day, and then effectively we fill in the blanks with that bookings table. Nothing particular profound there. But what if the requirement is subtly different? What if someone says, I want that same information on a room-by-room basis? So what I want is, I want hours 8 through 16 for room 1, and then hours 8 through 16 for room 2. So I want 2 sets of results. Now, why do I want 2 sets of results? Because there were 2 different rooms in the bookings. But obviously, if someone had booked room 7, then I need 3 sets of results. If someone had booked room 9, I need those same hours for room 1, 2, 7, and 9. It's indeterminate how many times I need to actually replicate that set. So it becomes quite a complicated SQL problem to solve, unless you're using this new syntax. When I say new, as in it's 15 years old. A normal outer join, but this time I can actually use a partition by clause inside an outer join syntax. And this simply says partition by the distinct values of room. So I get hours 8 through 16 for room 1 and 8 through 16 for room 2. And if there was a booking for room 7, I'd get a 3rd set of rows as well. So it's a nice, easy way of expanding data out based on the actual data distribution inside one of the tables. And I like that because this is one of the common things we have to do in Apex, is take sparse data, like bookings for meetings, and pad it out to fill in, for example, a calendar widget or some sort of widget on the Apex screen, which includes all the sparse data as well. So nice and powerful facility. Number 8, how are we all going? We're cruising along? Cool. Right. I know people go, I can see people just going, oh my God. So, pagination. This is a topic dear to my heart because no one does it well. Let's look at the most simple example. And so a lot of this will just, the first bit of this will just be hopefully you'll be going, yeah, I knew that already. Let's look at employees by hire date, most recent first. I put this slide in here because this was a question on Stack Overflow literally a week ago. And I always thought this was a solved problem. I thought everyone knew that you should never do this. But it still comes out. We have to understand the fact that we have new professionals coming into our game all the time. You can't do where row num less than 5 order by hire date because Oracle processes it in the order you see. It simply says, go get me 5 rows, any 5 rows, and then sort them. So yes, I get 5 rows, but it's definitely not the top 5. It's just 5 random rows sorted. So hopefully we all know that this has been around, we never do this, you get the wrong data. Typically we use an inline view. So we do something like this. Select from the table, sort by the hire date descending. Once we've done that, then get the top 5 rows. So hopefully all that's just, everyone just knows that, and that's just how everyone does their pagination. Or you can do something with an analytic function. This is actually the same kind of logic. We're using the row number analytic in lieu of an order by, but it effectively is the same result. And if you're on version 12, you can use the ANSI syntax standard, which is order by and then fetched first 5 rows only. And under the covers, we actually rewrite it to being one of the older style SQL statements anyway. We use an inline view, so it's really no different. So that's the solutions, and I'm sort of working on the premise that most people already are familiar with this. When people see this, they go, too long, didn't read it, too much hassle, I'll just let my app do it. Right? Because a lot of apps will do pagination for you. Apex is a good example. And so people who are, for example, Java programmers will say, look, I've got Hibernate, I've got something like that. I'll just write my query, order by. If I want the top 5, just open up a result set and fetch 5. That's just, it's the same thing. I had to sort all the data anyway, I'll just fetch 5. Or people say, too long, didn't read, I'm not a Java, I'm an Apex person. Apex conference. Apex can do it. I don't have to write the pagination code for Apex. I just do select star from emp, order by, and then say I want some paginated rows. Job done. For small sets of data, that's probably fine. For real life situations, it might not be such a good idea. I know this is going to get me offside with the Apex people, but whatever. Let's look at why it might be a bad idea. Just don't take my word for it. I'm hoping this was number 1. So here's my table called TX. It's lots and lots of copies of the DBA objects table, but that really is neither here nor there. It doesn't matter for this demo. What is important is it's got 10 million rows, and it's about 1.5 gigabytes in size. So it's a non-trivial table. It's got 10 million rows in it. Now, to see what it costs to find the top n rows, I'm going to use some Oracle database dictionary information. This thing called $SQL work area histogram shows me the cost for sorting across the entire database. And it's a running total. So if I do 10 queries that do an order by, all these numbers get updated. If I do 11th query, it's just a running total all the time. So to work out what a particular query costs in terms of sorting, I need to capture this information first, do my query, and then capture it again and compare the delta. So hopefully you can follow the demo here as to what we're doing. We have to see the delta in this information to work out what it costs to do a query that sorts. So I'm going to create a global temporary table called query before, which is a copy of this information. Now, let's do the recommended way of getting the top 10 rows. Select from TX, order by object ID descending, and get the top 10 rows. It took about 5 seconds. That's not too shabby. That's 10 million rows, 1.5 gigs of data in about 5 seconds on a laptop. Now I'll compare $SQL work area histogram to that snapshot we took of it before to get the delta. What did it cost me in terms of sorting effort to run that query? And the way this view works is it shows you different sizes of memory and how many times it had to use that memory. So in this case, somewhere between 2 and 4 kilobytes of memory it used twice. That's nothing, obviously. And somewhere between 1 megabyte and 2 megabyte of memory, let's assume the worst, 2 megabytes of memory, it used 3 lots of that. So ignoring that first line, we used about 6 megabytes of RAM to do that query, to actually get the top 10 rows. Now I reckon that's really impressive because it's a 1.5 gigabyte table. I have to visit every single row, obviously, to get the top 10. How did I sort 1.5 gigabytes in only 6 megabytes of RAM? Right? And now that's because the database does some really cool stuff. If I want the top 10 rows, conceptually you can think of it, I don't think I put a slide in, did I, for this? No. Conceptually what's happening is, to get the top 10 rows without having to sort all of them, I'll read the first 10 from the table. That's obviously not the top 10, it's just the first 10. I'll sort them. Now I've got those 10 rows sorted. And now I continue reading the table. I read the 11th row. Does it fit somewhere in that top 10? Yes, stick it in there, kick one out. Read the 12th row. Is that fit? No, it doesn't. 13th doesn't fit. 14th doesn't fit. 15th row does fit. Stick it in, throw one out. So I scan every single row. I have to. That's the only way of knowing what the top 10 are. But I never had to sort them all. I simply kept inserting them into this running list. Let's go back to our demo. So that's pretty cool. 6 megabytes to sort 1.5 gigs. Let's now repeat the demo where we've ignored that advice and we said, look, I'll just order the rows and fetch the first 10. So take a copy of my query before. This time I'm just doing a select from table order by and then just doing looping. Fetch, 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 get 10, I'm done. It's a little bit slower. The other one was about 4.9 seconds. But let's look at what the cost it was to sort. I used 2 lots of 4 kilobytes. No, it doesn't matter. I used 1 lot of 2 megabytes. 2 megabytes I used. And I used 2 lots of between 1 and 2 gigabytes of RAM. Right? And here's the key thing. It's not in this column, it's in this column because delta opt in this particular case means stuff I could do in memory. Well, I couldn't fit 2 lots of 4 gigabytes or 4 gigabytes of RAM in memory. I had to dump it out once to disk. It's a one-pass operation to disk. So if you don't tell the database that you're only interested in the top 10 results, if you simply say, do an order by and I'll do the fetching, I'm looking at maybe, 4 gigabytes of RAM to do that one query. Now, I don't care how powerful your server is. If you've got 500 users all doing that, you're in big trouble. So not telling the database that you only wanted the top 10, you just said do a select order by and then fetched, you're going to absolutely hose your users and hose your servers. So if you let the database know, you get benefits. So this is what we had. This is the query, the good query, and this is what you're looking for as a developer. If the execution plan says order by stop key, or the execution plan says window sort pushed rank, that's the keywords that are telling you that we're doing this special sorting optimization which doesn't have to sort the entire set. We're grabbing a batch and then logically sort of finding the best set as we go. So keep an eye on those keywords in your execution plans. That's telling you you're taking advantage of those sorting optimizations and not destroying your servers. And you get other benefits as well. My same table with 10 million rows, I'm putting an index on the object IE column, and that happens to be the one that I want to get the top 10 results on. So I create the index. Here's my good query, order by in an inline view surrounded by row num. Remember the first time we ran it took about 4 seconds. Now it takes no seconds. Now that's interesting because there's no predicate in there saying where something. Why was this of benefit? If we look at the execution plan, we have this full scan descending plus a stop key optimization. An index stores rows in order or entries in order. So to get the top 10 object IDs, I could actually walk down the very right-hand side, logically speaking, of the index and walk backwards 10 steps, doing a 1-row read each time, and there's my top 10 results. So I actually walked backwards through the index, descending, grabbed the 10 rows, and stopped after 10. That's why it was instantaneous. There's 10 very small IOs. If I had my bad query just simply order by and I'm just going to do a fetch on it, the database is not going to do that because you haven't told it, I'm going to stop at 10. This query tells the database, I'm going to get every single row of those 10 million rows, and the database is going, there is no way known I am walking through an indexed one row at a time 10 million times. That's far more efficient just to me to take the hit and do that big sort. So you lose the benefit if you don't tell the database good information. So we've got the top 10 rows. That's page 1 of our application. What about the next page? Well, there is no next page, as we probably already know, right? There is always a next page, but no one presses next page. You're on your Google, you search for rows. If they're not in the first 10 rows, you try a different Google search. Now, that's a bit flippant, but the reality is, don't assume that you need to get all the pages of your data just because someone wants the first page. And Apex obviously does this for you automatically out of the box, right? We run a new query each time we get to the new page. And we run things like this. Select offset 5 rows and then get the next 5 rows. So it says, skip rows 1 through 5 and then get rows 6 through 10. Right? And this is the ANSI standard syntax, and there are different ways of doing it that applications use. Don't do that. Right? Forget the offset clause. Right? It's a bad idea. Why? Unless you live in a perfect world where your data never changes, I'm not a fan of the way that we currently implement pagination in most applications. Here is my first 5 rows. So I'm getting the top row, employees by hire date. So these are the 5 recently most hired people. Then they press page down. And so we do this. Right? And that seems to look fine. That's offset clause. But whether we're using row number or anything, simply jumping another 5 rows down, this is conceptually what we're expecting to see. And that is the case unless there's some activity going on in your table. And generally, that's what tables are for, to have data put insert into them. If you do this, this is what you would see on the screen. Because it's a brand new query, we simply say skip 5 rows and this new one came along and we actually get to there. And so we had this confusion now because James appeared on the first page, but now he appears on the second page as well. And it can get worse. Let's not bring up my Twitter feed. Let's go to my Apex application. Let's sort this by descending, and we'll give you an example. So hopefully you can see this is sorted by order by X descending. This is a real application. We're currently at 1160. So I've got 1160. Let's hit page down. 1160. Looks like my application's broken. Press again. It's still broken. Now what's going on? This job is inserting about 10 rows every few seconds. This database is capturing 10 rows every few seconds into my Apex app. Every time I press page down, the table has moved on 10 rows, and so I get the same 10 rows. I am actually paging down. You can see it's 31 to 40, but 30 rows have come along in the time that I press page down. In fact, if I was inserting more rows than I was paging, I would go backwards, even though I'm paging down. Right? It can be, it's an odd experience for your users. Slideshow. This is how I propose you should do pagination in those parts of your applications where the paging experience needs to be performant and is critical that it's consistent. When you get the first 5 rows, you need to remember this one, the last row on screen. Your next query is not an offset query. It is you get the data where the hire date is less than the last one you showed to the user, and then order by, and then get the next 5 rows. Right? You need to remember where you got to give them a consistent experience as the next one down. Now, you don't get this out of the box with Apex, to my knowledge. Right? It's just not what we do. So if you have critical parts of your applications that need to do this kind of what I call ultra-consistent pagination, you'll need to code it yourself. Right? And this, I'm not suggesting you do this for everything because the vast majority of Apex applications are fine with their pagination as is. but there might be a few elements where you say, I'm going to go to the next level and take it like this as well. And the way you do it is generally, for example, maybe get the data into an Apex collection so you can remember where you were up to and then keep on going. So be aware of that. Now, expensive, how am I going for time? Oh man, I'm running out of time. You might still be thinking that's still an expensive query every time they hit page down. And this is true. This is how we do it out of the box in Apex and how most applications do it. You might want to consider what I call a halfway ground. I think Sabina's doing a talk on instrumentation later on today. So, assuming your applications are really well instrumented, you should know over time roughly how many pages people look at. So if I get an application which has 10 rows per page, and on average people page down 3 times, then I know that probably getting 30 rows is a good happy ground, right? 30 rows, give them 10, but now I can give them the next 20 without having to go back to the database for an expensive query. So you might be able to find a middle ground saying, on average, if I need to give someone, say, 200 rows in batches of 20, rather than getting 10 separate queries of 20 rows at a time, I'll get 200 at once and then feed them out in batches of 20. That's sort of a compromise between getting all the rows, which is ridiculous, and getting just the first page. Maybe there's a middle ground. So you might be able to do something like this. I'll go get 200 rows, even though I'm only going to show 20. I'll call that with the first 200, and then I'll give them just the first, in this case, the first 10 rows. And then when they hit page down, I'll give them the second 10 rows, etc. Now, obviously, this is still a brand new query. How do I let the database know that I'd like this to be done efficiently? Well, we can use what's called a result cache hint, which says, for this set of 200 rows, grab the data, cache it. When I run this next query, I actually don't rerun the busy query against this table, I actually go to my result cache. And therefore, for up to the first 200 rows, I might get some very snappy performance. Let's have a look at an example. We're back on our standard TX table with the 10 million rows, 1.5 gigs. I'm saying result cache, go get me the first, think of it as the first 20 pages, 200 rows. So I run it, but I'm just getting rows 1 through 10. The first time I run it, it took 3 seconds. I actually have to run the query at least once. That has now cached the first 200 results. So when I say page down, go get me rows 11 through 20, that's the experience the user gets. It's instantaneous. Why? We're using a cached result set of objects, and it's all managed by the database nicely. When I go get page 3, rows 21 to 30, because we cached the first 200, it's also instantaneous. And in fact, it'll be instantaneous until I get to 200 rows consumed, and then I would go on to rows 200 to, say, 400, and that would be an expensive query, and so on. But what we're hoping is to find sort of a middle ground where we say, we're going to give the user the best experience possible, and hope that they never page down more than 10 times. Something along those lines. And the result caching is good because it's managed by the database. If someone goes and messes with that table and changes the data, the cache automatically gets invalidated, etc. So it's managed by the database. We don't have to worry about cache invalidation, etc. So where does this, how do I link all this back to Apex? In versions of Apex up to 5.1.4, if you're on classic reports, right, they do, let's call it less optimal pagination. What they do is they simply do what I said is perhaps not the best example, which is simply fetch rows. Right? We order by and we fetch. Now, interactive reports do somewhat similar. Interactive grids do what I call classic pagination in terms of an inline view and the correct one query per page. Now, I wanted to put these up here, not so I can bag Apex, because I love Apex, it's my favorite tool, is that often when we produce new technology, like from classic to interactive report, interactive grid, people criticize the Apex team saying, well, why should I have to change? But by moving forward, because an interactive grid can look exactly like a classic report, you just turn off all the options. But if you do that, you don't just get a classic report, you get a classic report that runs faster and runs better because this is newer technology. So I know a lot of Apex people out there go, my classic report works just fine, I'm not going to change. But the reality is, you don't just get different UI in these newer technology, you get better performance, better functionality as well. Even if you take off all the bells and whistles. Okay. And the cool thing is, Apex 18 and onwards, in almost all of cases I can think of, right? The vast majority of cases, all these things have been refactored such that they just work as you'd expect. Good inline views for pagination, etc. So it's a real compliment to the Apex guys who have done that. Once you get to 18, a lot of this stuff is just going to run sweet. Oh man. Totals and subtotals. I promise I won't talk about pagination anymore. Let's say someone gives you this requirement. I want the employees, but I want a department level total and a grand total as well. So this is what my Apex app has to look like. If it's a classic report, I want employees, total by each department, and I chopped it off the screen, and a grand total for the whole thing. And if it's an interactive report, I could do it using something like this. Doesn't really matter, it's the same concept. If I run either of those and put a trace on them, do I see any kind of aggregation going on in the database? I don't. This is how we implement it in Apex. We simply get the raw data, and when you do those subtotaling, it's done in the Apex layer. We actually manually add the stuff up, come up with totals and subtotals, etc. Now, this isn't a criticism of Apex. We have to do it like that because, especially for example, interactive report, you could actually group and sum and aggregate in any way, shape, or form. You can say, I want subtotals, grand totals, aggregate by this, aggregate by that, get rid of that filter, add this filter. It's totally flexible. So we don't know in advance how you want to do your aggregations. But that's what we do. We actually get the raw data and then mechanically do the work of coming up with totaling. But if it's a fixed requirement, so just to flick back a bit, if someone says that's your requirement and that's the only requirement this app must deliver, if it's a fixed requirement, you can do better than just relying on any tool because tools have to accommodate all options. You could do it this way. Get the raw data, then get totals for the department, and then get a grand total. But that's 3 queries. That would be a really stupid thing to do. You can get from 3 down to 2. We could do this. Let's go get the raw data. That's the row level data. And then I can use a group by roll up, which people might not be familiar with, which simply says, get me department level totals and roll it up to a grand total. So now I've gone from 3 queries down to 2 queries. It's still a bit messy because then I've got those 2 queries that I now have to paint onto my Apex screen, which means getting the raw data and then, I've changed department, getting the little total, etc. That's a lot of pain, especially as an Apex developer. You wouldn't want to do that. You can get from 2 down to 1, right? You could do a query like this, right? It's still using a roll up, but we're taking advantage of the fact that row num is a number that's assigned to every single row. And a query like this gets you the raw data, the department level total, the raw data, department level total, and then the grand total in one SQL. That's pretty cool. That's going to be so much faster than a tool having to manually do the aggregations for you. And we are taking advantage of our business requirement. The business requirement was, it's a fixed requirement, this is what I need on my screen. I can do it in the database with SQL, one pass of the data, all the levels of totaling I want. So all I'm saying to this one is, take advantage of things that meet your business requirements. If you want full flexibility, the tool has to do it. Right? If you have a fixed requirement, maybe SQL can do it for you and make the whole experience much more fast for the user. You can get the whole lot. There's group by cubes. This will give me department level totals, job level totals, grand totals, etc. And you can even be totally customized in this. You can actually do a thing called group, sorry, because I had a slide up my throat, like 5 phones go out and I just went, I'll go next slide. There's a thing called grouping sets where you can actually nominate the kind of aggregations you want. I want totals by department number, I want totals by job and manager, and I want totals for the entire set. So I'm actually nominating, go get the raw data and just the totals I want. A lot of flexibility in the aggregation components for SQL if you have fixed requirements that just need to paint that data on the screen, and the database will always do aggregation better than your application tool will. Number 10. Oh. Let's talk about our last one. It's like seamless. Because I don't want to keep you from coffee, and I know I've spoken a lot. So the last one is really not a development thing. It's really a set of slides I put in almost every single talk because I'm really passionate about the database. And so the biggest risk to successful applications in any application environment, whether it's Apex or anything else, is distancing the database, not giving the database the information that it needs. And the way the world is going, we're getting more and more into that realm. And hopefully these slides will help explain what I'm talking about. Talking to your database makes it faster. Let's look at an example. I've got some stores. And for those stores, customers come in. And when those customers come into stores, they buy stuff and they make sales. So this is our data model. Stores have many customers. Customers conduct many sales. And here's a query that I'm running against that data model, which is, go get me the highest amount by each product whenever the amount of the product was, the sale amount was greater than $10. And the specifics is not really important. The question is, how do I run this? Right? And this is what the database came up with. The database said, well, I'll scan the store index, do a nested loop against the customers table, access the sales table with a hash join, etc. Now, the question that we often get asked as developers is that the best plan? You know, can you do better than that? Especially if it's running slowly. Should I add indexes to make it run faster? Should I rewrite the query? Should I maybe take that whole query and make it a materialized view? Maybe that result caching we spoke about will make it go faster. Maybe I should just give up and move the whole thing in Hadoop. It's a question we often get asked as developers. Here's my query. How do I make it run faster? Let's talk about how you can make queries run faster by sharing what you know as a developer with the database. So let's build. There's our stores table, customers, sales. I'm going to put 50 stores, 5,000 customers, and 1 million sales records in there. And I'll put some indexes on, etc., etc. And here's the query we had on the slides. And just to prove that I wasn't lying, that's the execution plan, which is the same you saw on the slides. So that's what the database currently thinks in terms of running that query. And this is what I mean by sharing your knowledge with the database. Tell the database what the primary keys are. Tell the database what columns are always going to be present. So I'm using not nulls here. Tell the database what the foreign key relationships are. Let's now have a look at this query again. Unchanged query. Right? Who wants to have a guess what the execution plan is going to look like now? Which tables are going to start with? This is a loaded question. Right? This is what the database does now. It doesn't access a single table. It doesn't read stores, doesn't read sales, doesn't read customers. In fact, the only thing it reads is the sales index we created at the start. That's insane. But this is what the beauty of Oracle managed to manipulate this query into only needing to read that index and nothing else. Because we shared information with the database about how the data related to each other between the tables, how the data was constrained inside the tables. If you can do that, your applications will run better and you didn't change any code. And I stress this because one of the great things about Apex is it's so easy with the SQL workshop and quick SQL just to get prototyping and up and running. It's awesome. But by the same token, once you've got a prototype up and running, take those database artifacts and apply your business knowledge to constrain them, to let the database know about how these are going to work in the real world. And you'll get faster applications just for free. It's pretty cool. So let's wrap up, because it's 10:30, and obviously we missed a fair bit of content, but that's okay. I'll come back. So SQL and PLSQL, obviously I think they are super cool. Right, and that's why I love talking at an Apex event, because you guys live and breathe SQL and PLSQL. Right, it's not like other events. It's incredibly powerful. The best thing is you get to write less code. right? If you put more power inside the database, you get to write less code and it just runs better anyway. It's never too early to start expanding your SQL and PLSQL toolset, right? This is my son, Max. Right? Yeah, he's an avid reader of SQL. He's moved on now to PLSQL. A little bit of glue there, be fine, wash right off. This isn't all fun. My son's actually now 13. But yeah, so that was a lot of fun back in the day. So hope you enjoy the rest of the conference. Thank you for giving up your time. I know it's an enormous amount of content we just slammed through today. Hopefully, to be honest, I'm probably going to go back to my room and have a little nap now. But then I'll be back for the rest of the conference. Feel free to come up and say hi, ask questions. Have a great rest of the day, everyone. Thank you.